So, when data represents an entire population, we call the mean, what's our symbol for mean? Thingamajigger with an X, X bar, yeah. But guess what? This is math. Hey, this is the English language. Why have one way to say it? Why not multiple? When data represents an entire population, we call the mean previously given as that, and that's what it says on your calculator. You know what that is? Mu. Yeah, mu. He's taking physics. That's Greek letter. Is it M? I think it is M. Mu. Think of a kitty. Think of a kitty cat. Mu. It's a U with a little curly tail, just like, remember standard deviation was an O with a curly tail? That's a mu. Let's write it. Mu. That's how you spell it. That's it. That's another Greek letter, okay? First one you got was pi, then you got some other ones. We had a sigma, now you got a mu. Okay? If I didn't come up with this stuff, I'm just the messenger, right? If a graph has a mean, known as x bar, or now we call it as mu, if the graph has a mean close to the, you remember the median? Median's the middle point, remember, of a bunch of data? The mean is like what you used to call the average. There was also mode too, wasn't there? 3 types of averages. So if a graph has a mean close to the median, there is a good chance, real good, chance it will look like a, what I was talking about, a bell curve. Or what's another word for a bell curve? A normal distribution, which is the title of today's lesson, boys and girls. Okay? Now, there's lots of stuff going on in a simple little bell curve. So let's draw one. Nice and neat. And nice and big. And this thing should look symmetrical. What else did we do that was symmetrical? Parabolas, yes. Left side looked like the right side. This isn't a parabola. Looks like a funny upside down U. Looks like a hill. All right? But the left side should kind of look like the right side. Nice and big. That is a normal distribution. Right in the center, we got a dashed line down to the bottom. And that is the mean, which we now call mu. Okay? On either side, just a wee bit, like don't make it half the way, There's a dotted line there and equally spaced. On the other side is another dotted line. On the right-hand side, that one is called mu plus sigma. What was sigma again? That thing, standard deviation. That's what we did yesterday. Okay? On the left, we have mu minus a standard deviation. And then we do another set of dashed lines on either side. Should be kind of the equal distance. If that was mu, and that's mu plus 1 sigma, guess what this one is? Mu plus 2 standard deviations. And this one is mu minus 2 standard deviations. It's bad, like real bad, bad. I told you, make it nice and big and nice and neat. What does big mean? Like when I say on a project at least half the page, and some kid puts a little flippin' graph way up in the right-hand corner. Their name's like this, but their graph's like this. Okay, do your best, okay? One more. So guess what this one is? Yeah. And that's going to be the last one. Mu minus 3 standard deviations. Oh my God. Okay. This first line here and that first line there on either side of mu, if this is a standard deviation, if this is a normal distribution, 68% of all the data is contained within that little space. Okay, guys, Savannah. Okay? Within plus or minus 1 standard deviation, that's 68 or over 2/3 of the data. Within here and here, that is 95% of all the data for a normal distribution. Like, there's not much left, is there? So this graph doesn't look that accurate. These lines should be way down here. But anyway, these numbers are correct. Within 3 standard deviations, that is 99.7% of all the data in a normal distribution. So how much data is not contained within 3? Don't do this on yours, because I'm going to get rid of it. That's 3 standard deviations above and 3 standard deviations below the mean. How much is not contained with there? What's 100% minus 99.7? 0.3% of the data is outside of 3 standard deviations. Okay? Does that kind of look heavy duty? So, one thing I told you to do, and we want to make note, this is symmetrical. Okay? Another word for this says it, but let's write it here too. That's a bell curve. Now you don't have to memorize this. I will give it to you in that picture form on your test and your quiz and your final, which is how much of your mark? 20%. You want it 30? Okay, done. Let's go 40. Come on, 40. Do I hear 40? 35, 35, 36. Come on, going. Now it's 20. Okay. So, I said it, let's write it. 68% of the data is within 2 standard deviations. From mu. "95% of the data is within 3 standard deviations from mu." I know some of you stretching your neck. I'm trying to make this as big as possible. There we go. You know, I pray, Braden, you become a teacher, and then kids keep saying suggestions to you all class long. Why do you do this? Why do you do that? Why do you do that? Why do you do this? Can I go make popcorn? Okay? Then we would call that justice. There's another word for justice. You know what it is? Grandkids. Okay, 99.7% is within, that's incorrect. 1 standard deviation, 2 standard, 3 standard deviations, okay? Fix that. Okay. We got that? So for example, okay, that's it for the heavy duty graph. For example, someone gets 72% on their tests. That's their mean, known as mu, okay? Their standard deviation, let's say, is 6%. So 68% of their test scores. All right, I gotta hit the page here. Fall between what and what? Give me a sec. So 68% of all the data falls within 1 standard deviation. For this question, someone got a mean of 72%. Okay? Their standard deviation was 6%. So mu plus standard deviation, what's 72 and 6? What is 72 minus 6? So 68% of their data was between 66% and 78%. All their tests, 68% of them, or over 2/3, were between that, assuming it was a normal distribution, which of course is what we're doing. Okay? Given mu, given sigma, so 95% of their test scores are between what and what? How do you spell between? %. Let's use a different color. Are within 2 standard deviations. So I'm just going to add another mu. What's 78 plus 6? 84. What's 66 minus 6? 60% to 84% is 95% of all their test scores. Okay? It's not that hard to stuff. You just got to look at the table. Okay? It's really not difficult. Parabolas are more difficult than this. Okay? One more example. Sketch a normal distribution for I can make a nicer sigma than that. Okay, B what percent of the data is between 37 to 44%? Page again. No. Because before we get our answer, I will show you what she did in her head. So when it says sketch a normal distribution, here's how easy it is. Okay? You're going to draw one of those. What goes in the center? Mu. What's mu? 37. The first set of lines is mu plus sigma, which is what? 37 plus 7, 44. What percent of the data is between 37 and 44? That's what the question's asking. Sketch a normal distribution. There it is. Actually, I didn't completely do it in. If I want, well, what's 37 minus 7? 30. And the next one is 30 minus 2 7s. 37 minus 14, or 30 minus 7. Doesn't matter which one. 23. That's 44 plus 7. 51. And there's one more, 51 and 7 is 58. 23 minus 7 is 16. There's a normal distribution. Took me 20 seconds. Now, how did Smarty Pants here do this? Remember, this thing's symmetrical. What is the value of percent from here to here? I kind of hacked this thing up, but what is that? 68%. Is this thing symmetrical? Okay, that is 68%. So what is, does that look like about half? It's symmetrical. If that's 68 then, hey, look at that, eh? Purple and yellow make red. What's half of 68? 34% of the data is between 37 and 44. Okay? He doesn't need to. There's the answer. Okay? Can't you see the purple lines underneath the red? Hey, look at that. All right? What percent of the data is below 16? Last question. I'm not even going to write it down. That's here. Okay? Below 16. Well, this and this, remember we said that makes up 0.3%, this and this. So if I just want that, that's half of 0.3%. 0.3 divided by 2 is 0.15%. Not very much. Okay? It's not that hard. And if your picture really sucked, this is on page 250. Okay? Feel free to look there when you're doing your questions if your notes are really terrible. Okay? Same picture. That's it. 251, 1 to 4. Do this, get on it, time's running out, you only got a week to catch up, and rewrites, names go on the board. There's 4 up there now. One's awfully big.